Okay,
Okay,
go,
so
Mark.
let me just give me a tiny second. Okay, I can leave the other computer here, heating my room because it's a toaster. Literally a toaster. Anyway, can you guys see this? The normalization written blah 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 with a minimalistic thing. By the way,
Yes, we
you can
can.
interrupt me as I go. So I'll try to be more eloquent here as I speak. So the topic of this talk is normalization, but I wanted to introduce as well some other fundamentals that I think are very relevant for when you to introduce like relational databases to people. So I think those topics they are often very well mistreated by modern practices. If you look, I don't have the feeling after reading this book. I will mention this presentation, by the way, was heavily based on a book from Fabian Pascal, which is one of the most like one of the people that I consider most trustworthy on databases. He's like very heavily into CG data and so on. Um, so and very close to like the source guys. So like for example, COD, which was the dude that designed the first the relational model idea and so on. So is it too far? By the way, let me put it like this.
It's
So
very fine.
all right. So I wanted to basically introduce, along with the idea of normalization and giving a warrant why you would want to have normalization, uh, the idea behind why you need normalization and why doing something like denormalization is not actually something good. So let me begin. Can I? Okay. So the confusion. I think if I were to start, I think the best way to start is about displaying the confusion. And I totally understand the problem people have into introducing themselves into the relational theory. Because the main problem I see is there are so many terms and so much background you gotta have that it makes very hard to make an entry level talk that you are precise and you share share the topics in a way that the practitioners, like the people who are actually not really that much interested with the whole theory, they want more to use the theory um, to actually have something out of it, right? To like work and so on. And I'm not here blaming those people. I do think though that if you jump straight ahead to uh, the practical part without considering the technical part, the I forgot the word. Oh man, the
Theoretical
theory.
part.
Yes, thank you. The theoretical part, then it can become quite that leads to severe consequences, I would say. So I also think though that most of the things that people relate, they're wrong. So for example, people tend to think of SQL when we talk about relational. So I was reading this database announcement. Like I don't remember what was the name, but it claimed to be a post SQL. So it was claiming a post SQL era. The post SQL era has arrived, and okay, like I'll not judge whether that or not is true or what is the concept behind the database. I didn't even read through that. But my point is, I think it's a false relation to say that SQL is relational because it is not. SQL is just a declarative language that people happen to do relational model very badly, but it serves to do that purpose. So it is a very bad mapping. So that's one point I want to make here. But also terms like if you pick out terms for things such as temporality, which I'm studying right now. Uh, you have transaction time, you have log time, you have valid time. You have many different notations, but in more or less the same way. They're being used exchangeably throughout the literature. So it's really confusing to read one book and then go for another book, and then they have totally different terms, meaning things that lead to terrible consequences on both sides, but they mean the same thing. So that is part of the thing, and I hope to bring closer like some core concepts of again, these fundamentals so we can discuss. So, what is in fact a relational database? And the fact here is kind of a pun because what to you means to have a relational database? Can you give me an answer, Lemos and Nathan, since you're here? Just to make it more interactive.
Okay, so as far as I like, my first guess would be that a relation is a mapping between two sets.
Okay, like picking the mathematical definition, a relation is something you can use to construct sets, right? I put it that way. And you can pick something like, for example, lesser than, like that's a operator, right? Something like this that you can stipulate that to be a relation between two things in a set, right? Or sets, whatever. Other things like functions, they could be relations as well. So relations is kind of a broad topic, right? When you speak about like this topics in set theory. So just give me a tiny second. Just give me a second. Okay, sorry. Okay, so where was I? I forgot where I stopped.
We were talking about a first definition to a relation.
Okay, so all right. So what would be then a relational database? It is a collection of of propositions that represent things that you know that are facts. So what does that mean? You have a structured way to store, because it's very easy to think of databases as storage, right? You think of it as, okay, a place where you store stuff. That's the database, right? It's something you store stuff. But I think that's a thing that can lead to miscomprehension of what the relational database intends to do, because it is not merely storage; it is storing truthful, structured facts. So what does that mean? You are trying to map things from the real world into your database given constraints, and those constraints they will give you like you can call them business rules in this case. Those things that you're trying to map, they are things that you represent truthful statements, what you believe at that moment. So I'll make a parallel with type theory. We think of type theory as types as propositions, and we pick values as proof, right? So in here it would be analogous to that. Like we have relations, uh, and then we can define like prepositions, predicates, and all the logical system. So our database is really a logical, like it's being constructed by a logical system. That's what I want to say. So you basically have the rows like of a table, I think like that, something like that is representing truth at that moment. So that's the idea behind the relational model.
I have a question though.
Okay, go on.
So, what would be? Could you repeat what would be your definition for what is a relation?
Okay, I didn't. I guess I didn't define it. We can look at a formal definition for it, but
You should have to give me a loose definition, just like a short version of it.
okay, I'll pick using the idea of databases. Okay,
Mm-hmm.
so when I say okay, a relation in a database, what do you immediately think of?
Two circles and an arrow.
Yes, you think of the arrow, but that is the thing. That is the thing. You're thinking now of the table, right, as the domain. Because think about this: an arrow goes from one domain to another,
Yeah.
right? But that's wrong. You shouldn't be thinking of that the table as the domain. I mean, it could be you're defining constructs and so on, but the idea here, as I see it, is the relation is the you can consider. Okay, I'm gonna butcher completely. People will cringe, like, but think of the relation as the table. It is wrong. It is not the same thing, but think of the relation as the table.
What?
So now what you have as a relation is the tuple. It is the definition that it goes on the table. So you think of the heading of the table. That would be the relation in this case. It is the
Okay,
thing that is giving
I
you the
got what you
structure.
mean. I got what you mean. But I just want to make sure that I'm understanding correctly. So would be the table the the implementation of the arrow?
Okay. Oh man, it's getting because think about this. Like, what is the arrow? An
That's
arrow is it's also representing a relationship, but
I
it's not the
agree.
same thing. But
Okay, it's not the
why?
same.
But why do we have the arrow to begin with? It means that we have a foreign key that is represented here, like, and we are having a multi-value dependency, blah blah and so on. So what you're having here, like, is okay. I have one table that is linked to the other table, right? So in truth, what it should be is that you have a the name they use for that is a relvar, which is a relation variable. So I can show them on my demo later, but the idea of this relvar would be to have on the relational model a thing that is equivalent to a variable. And what is the equivalence to a variable? It is a variable that assumes relations, that assumes these values, these propositions at the at its evaluation. Let's think it that way in like terms of programming languages and such.
Okay, no,
So
we can go on. I will, but thanks for the answer. I will keep,
okay,
let's go.
I don't know if I answered though, but let's go. Okay, so I think I will give an example. It will be clearer. But anyway, and I and I also think there is this uh, idea behind it, which is we have this idea very deeply rooted by the Enlightenment and empiricism of finding a method to do things. And I don't necessarily believe of this as the most optimal idea behind before understanding the problem. So what do I want to say on this is you are swapping the theory again by practice when you do this. Because what do I want to say with using a method? People when you look at like usually tutorials on like the normalization, you basically read, okay, you do this, and you do this. And then you ask yourself, why? And then you don't find the why because people are not concerned with knowing the why behind the things. They're just concerned because, I don't know, they want to do normalization and they want the supposed effects of normalization. So, what I want to do here is walk step by step, providing the rational why normalization matters and why and how to come up with the idea to make normalization actually something. So let's talk about first of integrity and rules. So what is integrity in our context, right? So imagine like this: our database is basically supposed to represent things that exist in the world. So you have like some operations that happen like a company or something, and you want to structure that in a database. So what we essentially do is that you start to look at the constraints that you have in the world. Like for example, this contract here doesn't cannot be uploaded before cannot be finished before the other contract here that is like I don't know in a process of a random place in a company. So that is a constraint that you have dependency on things, right? So that would be a business rule, like some rule that exists in the universe, like it exists in your realm, and you want to map that to the data level. So you want to bring that over to the relational model. So what we're trying to do is not to encode physical truth, which is like uh, things that are contradictory in the world, but we're trying to encode things that make sense within the context of these rules. So I guess that's the idea. So having an integral database in this sense means that you have the full ability to have a system that where everything inside of it is trustworthy. Everything inside of it is true. So I'm not saying this. There are two concerns here. I want to make it clear. So the first one is like people think of like the ACID, right? Like persistence, writing to the disk and storing it there and making sure stuff is stored. That's not what I'm talking about. That's the a mechanism layer. What I'm talking about here is the ability to know and trust on the database on what is in there and all the predicates, all these things that you can claim with placeholders, like, okay, at this time, this person was at such place, things like this. And you can claim those things that and say that they are true in the context of the data you input on the database with your business rules. So that is the idea. So being integral and respecting these rules means that we represent accurately the world. So that is the idea. So we end up with a truthful logical system. So there is this golden idea on database, which is on relational databases, where everything on the database, every constraint, your database is integral if everything that you set as a constraint evaluates to true. So you can basically do a bunch of checks, and after those bunch of checks, you reach the conclusion that your logic system is true. Like everything is concise. Consistent. Everything is fully represented there, and everything makes sense with the rules you inputted, of course. So that's what we want to reach. And to reach that, we need to focus on normalization, because the process of normalization is to bring closer something that is being mapped wrongly to something that is being mapped correctly. So what do I mean with that? Think about this. You are designing the thing, right? In a relation, there is no such thing as a relation that is unnormalized, that does not exist. That's a contradiction in terms. The definition of a relation implies that it is normalized. So what we're saying here is, okay, when you hear of something like, okay, so why then we have normalization, right? That's because a table can be unnormalized. But relations are not tables. They are representations for a relation. So that sets the whole difference apart. So what is the main problem here to invoke first in the first place the idea of normalization? As I said, normalization is to bring closer, is to fill all the gaps of anomalies and all the gaps of redundancy and all the gaps of things in between your model that can lead into some inconsistency. So that is the primary goal. So when people think of, for example, I read this article of the dude who was talking about denormalization. Like he was literally saying, okay, we should denormalize stuff to make it fast. And think about this: if you denormalize stuff, that means that you are adding a lot of nulls everywhere, a lot of like stuff. And where does that come from? Because, well, it makes easier if you're not doing joins, right? But what I'm saying here is that I'm not concerned with the joins. Like that's not the thing, because you're thinking of two different abstractions, which is you're trading like this supposed speed you gain with it on like doing queries and so on with consistency. So you're now risking having something wrong in your data to have speed, supposed speed. Like, okay, so that is the rant. I just wanted to rant news. So anyway, I think that's it on the slides. I will go to GNU Emacs. So let me share here. Change windows. And where is my Emacs? Where is my Emacs, man? Oh, here. I gotta bring it over. Back. Can you guys see? It's just a blank screen.
Yeah, blank screen, yeah.
All right, so let's bring it on. So I will I'll first start talking about what is normalization, okay? So there's first a very important distinction. So normalization implies that you have stuff at first normal form. That's it. If you have something in first normal form, that means that that thing is already normalized. That's it. That's it. When people say, okay, like fifth normal form, that is further normalization, or I think some people say fully normalized as well, which is beyond the first normal form. And okay, so there is a clear distinction. When you say normalization, we're not necessarily talking about all the things, because that gives an impression it's a hierarchy, which is not. Like some of them actually are, that's why they're numbered. So for example, the fifth normal form Oopsie. Fifth normal form requires, it's not an implication, but I'm just going to use an arrow. So a fifth normal form requires the table to be in a fourth normal form. So that's something that has an hierarchy, but it's perfectly possible, I think, for the second and the third to be like one and not the other, if I'm not mistaken. So it's not, don't think of it as like a clear hierarchy that you go progressing like in a in an order. So okay, I have one table here I made. Oh man, let me, should have brought the buffer, but anyway, this. So it's good that I can use org to do this, right? Oh man, sorry. Anyway, so this is a table that I have composers. It's just a cheeky example, but I have composers, names, they, it should be genre, I guess, but not class. But anyway, like categorization for it. Where my favorite piece of music is in, and the amount of them. It's obviously fake, like it's all wrong, but who cares? Um, so okay, so we have these codes here that represent these people. So we have Mendelssohn, Varese, Fauré, and Elgar, and you have the genres and this. So this table is already normalized. Why? What does it mean for something to be normalized in the beginning? What we want to do is to represent things in a truthful way. What does that entail to? Is that you're basically defining things and analyzing their dependencies on something. If they only exclusively have dependency, if they have a dependency on the key and exclusively on the key, then that means that has like a lot of implications, but just get this for now. If you have something exclusively pointing to the key, then that means that something like is in a normal form. So in this case, it's very easy to see that, well, everything has just a dependency on this key, right? This is the key, by the way. This is a number. This could be like with both, I guess, the name and this, or perhaps the name, this, and you'd even ditch this. But anyway, or just this. So there are many possible keys here. That's what I'm saying. There are candidate keys. Oh man, I'm sorry. I can just coughing. Okay, so and this data, which supposedly is not unique, they are pointing that they don't have any dependency in our predicate, which would be there is a composer with that has many categories. And this could be perhaps this is not a good one. Let's just put tell me a composer, Verdi. So, oopsie. So you have these composers. Let me just change this. You have these composers with these codes, and they have this class, blah, blah, and so on. So what you're saying here is that, okay, I have a composer with the name blah, 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 which is a placeholder, on class blah, 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 which is like, I don't know, this is realism. Who cares? On the first period. I was thinking of anything, really. So Mendelssohn is not even realist. But anyway, with my favorite piece at the date X, and he released this many pieces. So what I'm saying here is giving you a statement, right? I'm giving you something that is true. Like, I like this guy that did this, blah, 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 at this time, and he has this many things. So that's an example of a normalized table, because everything here is pointing directly to the key. There's no dependency on, okay, this thing here depends on being this. Okay, maybe there could be, but we didn't add that rule. So that's the idea. Okay, so so let me read this thing, which I think is very important. So let me just get it here and dump it here. So just do this. So note very carefully that correct and complete mapping of a conceptual business model to a logical model will always yield fully normalized tables. That is the McGovern's conjecture. That there are three principles: parsimony and so on. Just give you the name. It is only if and when poor design has bundled multiple entity types into single tables that those tables must undergo an explicit process of normalization. In other words, normalization is a redesign process that unbundles those entities and eliminates the complications that you have from it. So I think this is like really well done. This is from the book I mentioned from Feynman Pascal, uh, topics in databases and practical issues. I get the title by the end. I don't recall exactly. But that's the idea. Okay. So let's begin with the normal forms. I guess that we can start. So what is the first normal form? What does it mean for something to be normalized? What do you think, Lemus? That something means to be in first normal form. Think of the dependencies, I mean.
Every single, I don't know how you would call that, but like in terms of the table, every single column is only depending on, all of them are pointing to a single one, a unique one.
That is fully normalized, but yeah, it fits on the first. Like, here's the definition I got. I rewrote to make it easier. So, in terms of a table, since there's no such thing as an unnormalized relation, I already mentioned, it means that the rows conform with the heading. That's the CG Dates definition on his classes. It's like a very easy definition. And have no multi-valued columns. So, one example of a multi-valued column would be something like this. I think people often use telephone, but I don't think it's a good example. Here. So I made favorite programming languages for each of us. So you have Nathan, that likes OCaml and Java's something. Breno, that likes Golang Fast Raw Pike. Smalltalk, F# Clojure, Haskell. And what is represent is that there's some duplication here, right? I didn't type because whatever. But like this could be also like a list or something like F# Clojure. So you can clearly see that this is nested, right? This is what he calls on a bundled attribute. So this is a relation by itself inside another relation. So you're trying to fit two things together, and you end up with this. So this, by the way, like this on query level, I think most people care about this because this makes really bad for you to query stuff. For example, especially in SQL, I think it gets really hard. But then if you normalize, that means bringing over things that are like with this structure to the key, to a dependence on the key, you end up with this. So let's go on detail. So what does it mean to be this? It means that we are bringing the name to the key, and we're bringing the language to the key. This is a person number, by the way. That's the per. Anyway, so we now can define this like this. So we have another relation that basically says, okay, this person is attached to this key, and this person is attached to this name. So those are two different things. So first normal form, I think it is fairly easy to get a grasp on. It's not very hard. But the key idea here is behind this conforming with the heading. So everything that you say here conforms. And to be a relation means that you don't have duplication in rows, which you could possibly have on the key, I mean, which is this guy. Unless you lift the key, but anyway, that's another story. So the idea would be bringing these things to the key. In this case, I even lifted this as a key because, well, this has possible duplication here, but, well, it's only a combination of two things, right? Like this person liking this language, this person liking this language. So that's the thing. Is it clear or was it confusing?
I like it.
Okay.
Yeah.
So I wish I was taught like this, by the way. Like it was way more convoluted the way people taught me. Okay, so second normal form. So what? Oh man, I keep saving. I don't need to save. So what is the second normal form? So the second normal form, I have the example of a table here. So the second normal form, this is from the book. The second normal form is something that all the attributes, all the columns here, they are functionally dependent, and I'll explain what is functionally dependent, on the whole key, not just part of the key. What does it mean? Keys, they can be composite, right? So you can have like a key that has like three attributes in it. Like in this case, the key would be this and this, right? So what we have here is that, let me just put my thing here. So what we have here in this case is that, okay, we have a dependency somewhere. Still don't know what yet. And this dependency is causing me from looking at only one part of the key, not the whole key. So you are governing your attributes in your database using something other, using something that is also dependent on the key or dependent on something else, which will eventually lead to the key. But anyway, so uh, this can lead to a bunch of like other problems. I can list them here. But let's break this down with some business rules. So let's provide some interpretative meaning to derive something out of it. So the things I added here were these two. So let me paste here so it makes more sense. So in this universe, this thing we're trying to model, the staff is on a per project activity, meaning the staff, let's bring here. So the staff is on a per project activity. So it is a coupling of the project and activity, right? And the managers are in the respective departments, they are assigned to projects. So translating this, it means that we have the department and the project manager dependent on part of the key, which is the project. Can you see this?
Yeah. I see now. The example was great.
So let me just draw, let me type here. I think it's easier. Somebody didn't get it. So I think I have the so the projection, the project number, and the activity, right? So we have these both, these two, and the staff is on it. That's fine. The whole key, right? And then we have another thing, which is the project. How do I type in project manager number? Should have like the project manager and the department, because the project manager is in a department, they are dependent on project. So this is just part of the key. It's not depending on the activity itself. So this is an example of something we need to break down. How can we break this down? Well, this is fairly easy. Like we can just make another thing here. So I don't have the here, so I have to do it. To see the dependencies. So a thing that is on project and something that is on a project manager. So PMGR, blah, blah, blah. And another thing that is finally the department that that manager is in. So this is adding a dependency on this second rule here, right? So you just add the roles here with the respective things. So I'll not even type this. I guess you guys can get it.
I have a
And
question.
go on.
Okay, would you say that, from my
Mm-hmm.
understanding, the first and the second normal forms, usually you are grouping stuff that shouldn't be grouped in the first place, and the solution to that is to break it down.
Yes. That's the idea of multi-valued dependencies. You multi-valued dependencies means you have grouped stuff. So that's it.
Yeah, because as far as I can tell, the solution to this problem will be to remove the columns of the project manager and the department and make
Mm-hmm.
them binded with only the project key, and the project key and the activity be binded just to the staff.
No, wait, say it again, the last part.
So my understanding of the solution would be you pick the project manager and the department columns of the first table there. You remove
Mm-hmm.
those. So then you're gonna have
Yeah.
a table with three columns: project,
Yeah.
activity, and staff.
Yes,
And then
which
you
is this.
and then you make the second table with the project manager, and the department.
Yes. That's
So
it.
yeah, okay, so it makes sense.
So also second normal form, I think it's fairly easy to grasp. I think it is like these are very straightforward, right? Because as you said, you're literally trying to degroup stuff that shouldn't be grouped together because So that's the second normal form. And like this is basically killing redundancy at some point. So I guess he has a thing here. Let me read this. So projection number values repeat causing their dependent project manager and department values to repeat. So what we're doing here is like breaking this dependency, so we don't need to repeat the this a relationship. I don't want to say relation. This relationship between those two. See? So, thus, when the manager of a project changes, the role of all the activities of a project must be updated. So that is the idea of you're preventing yourself to suffer from update anomalies, right? You update something and then you cause a bunch of effects in your database that like should side effects. Let's put it that way. That shouldn't happen. Like you need to, you're possibly introducing inconsistency of having data that is false.
Yeah, if you don't do that, if you don't update all the repetition, like all the keys in the unified table, then you're gonna have run the risk of having non-trustworthy information.
Yes. Okay. So third normal form. I don't know if I'm running out of time. I want to at least go to third normal form.
No, you are in the 36 minutes mark.
36 minutes, dude. What the heck?
Yeah, you have
That's a lot.
24 left.
All right. That's a lot more than I expected, but that's fine. That's actually good, but anyway. So third normal form. So I read the definition. I wrote a chewed down definition. So
Could you copy that down? I think it's
yeah, I
better.
will. I will. Yeah. Put it here. This. So if all columns are functionally dependent directly on the whole key, in other words, no column is dependent on a known key, which would be indirectly dependent on the key. So some column, this is like some sort of transitivity, right? Uh, if you have something that is dependent on something else that is not part of the key, then you need to eliminate that because that's indirectly dependent on the key. So you're governing some data, some attribute, not by the key, which is the thing that you should use to know to get the consistency and so on, but you're instead focusing on something that is looking through that. So you're having a second degree thing here. I guess it makes sense if I say a second degree thing like this, right? Like
Yeah,
anyway.
no, makes total sense. Yeah, you're adding bottlenecks basically.
So the example he gives that I got here, which I think is a good one, is this. So what is happening here? I have the two things, and then we can write the thing. So what is the oopsie? So those are the rules. So departments, they are assigned to project managers. Project managers are assigned to projects. So this is pretty clear, right? We have, okay, departments are for project managers and project managers to projects. So what would be the solution here to break this dependency? Can you think of something?
Yeah, I can. So the one that is farther away from the key is the one
Mm-hmm.
that should get removed from the table.
Only that one, but just it alone,
No,
like
not it
this,
alone. You need to
or
like
what?
the key that is indirectly assigned to.
Mm-hmm. Which
You
is
also need
the
which is the project manager in this case.
good.
You should
So
also
then,
bring that down with you.
yes. So that's it, right?
Yeah, that's
And
pretty
then
much
you
it.
have another one, which
With the
is the
project and the project manager.
good. That's it. So you're getting why I'm saying like it's a lot easier if you do this. Like you're literally getting the idea behind the thing. That's it. That's it. Easy peasy.
Yeah.
So I think the first three they are the easiest. Then the fourth, the fifth, they are kind of hard. The six is like more. Six is actually easy. But anyway, so what we would have here, it would be a relation like this, right? So you have proj to PMGR to a department. This, right? So this would be our relationships. Okay, let's do fifth. Oh, fourth. Fourth normal form. We're almost finishing, man. Okay, so what is fourth normal form? Now I introduce something extra, something fun. Let me just get here. Let's see here. Here's the definition. I even tagged something to make it easier. If no multi-value dependencies exist between columns, multi-value dependencies means the set, they're called MVDs, I think, the keys. It means that sets of values in one column are each associated with other values of another column. So it is a relationship of many to many. Can you see that? I have an example here. Let me bring the table. This. So where is the relationship from many to many? Well, it's on this activity and this project. I guess project here wasn't a good choice, but you have employee, so an employee number, so whoever is performing something on a project with this activity. So people can perform many. I have the things put here. Here. So an employee can be into any project doing any activity. An employee can be into the same activity independent of projects that he's already in. A project activity can have multiple employees in it. So what are the problems here that you can see? the most like the direct thing you can spot with this problem.
Well, you have multi-values stuff that we said in the beginning, which is bad.
Uh, you can basically you're introducing an idea that if the vin if the employee number, like imagine like this, they're all keys, right? In this case, there three of them are keys.
Yeah.
They need to be, but uh, the values here of employees, if they cause any repetition, they're also causing the project to repeat. So that's introducing redundancy. But not only that, but they're also causing the activity to repeat. So
Oh yeah.
you're basically having this. I guess he uses another arrow. Let me just check here on the book. Second. Wait, where did I put it here? Yeah, okay, so he uses this thing to use it. I don't know what he doesn't explain exactly, I think, but what he's saying here is that okay, you have this dependency on the employee with the project but you also have this dependency, which we will see on the activity. So it is a I think this is just represent a many to many, that's why. So you're having an unlimited different who is there by the way? Victor? I don't know.
Commander entered the scene.
Oh, hello, Commander. So you're having now multiple things that have multiple things that have dependencies on things that have multiple things. So does it make sense if I speak like this? Quite convoluted,
Yeah,
but
I can try to rephrase it. So
yeah,
you
please.
have multiple employees, and each one of them
Mm-hmm.
can be doing multiple activities in multiple projects.
Mm-hmm.
So you have like three sets of things in which they can have. Each one of them can interact with each other in a like an n like a multi-value stuff.
So you're having here a m to n relationship that you
Yes.
need to break down into n to one. Many n into ones, right?
Yes.
And how do you make these n to ones? Well, you make a new key, a new table, and then you inherit the key from one table to the other. So you have a common key on both. That's what I'm saying. So let's try to do this. So this would be something like this. I think I have here. Yes, I do. So this would be something like this. You bring the thing that will be in common with them both, and that will govern one of them. So they're all keys in this case. They're all unique. So we can just bring the employee as the binder. The binder, is that a good name? I don't know. The
Um,
employee number?
Identifier, I guess. Like
Identifier,
representative.
yes, better. Representative, okay, that's fine. And then here you have the activity. So now you're having the same. What the heck, man? Okay, I found a bug on org mode. But anyway, that's it. So you have now two things that are broken, and they have the thing that is in common with them, which is the employee number. And this thing is directly, and they're both keys in this case. So if we were to add, this would be a key, this would be a key, and this would be a key, and this would be also a key. Right? It's like this. So is it confusing?
No, I think I got it. I don't know about Nathan Commander, but
Yeah, I don't know about the rest. So if you guys feel anything is confusing, let me know.
yeah, I'm reading the chat by the way of the channel here
Okay.
as well.
So let's go to fifth normal form because I want to go to six. I didn't prepare for six, but I think we can go there.
I don't even know what is fifth and sixth to be honest. So
They are the hardest ones. So I think the six is not that hard though. Like I think it is fairly easy. Uh, the problem is the modeling behind it. That's hard. Uh, okay, so what is the fifth normal form? The definition, I think it is terrible. Like I don't, I rewrote the definition on a way I can understand. So let's see if we can here. So if no joint dependencies exist between columns, joint dependencies are dependencies where some transitivity is possible. That is not really true, but I guess for us to understand that enough. But here's the idea: you gotta dismember this thing into many relations, like one.
wait. Can we start by what is transitivity in this sense?
Yeah, transitivity would be sort of like this. Like you have something that is a many to many thing.
Oh,
So not only that, right? Transitivity is actually something. Sorry, that's actually. I think that's actually wrong. Like a transitivity would be something that is uh, depending on something that is not part of the key, because that something is also dependent on the key. You
but
got the idea?
yeah,
So
but wouldn't that be like the third
yes,
normal form problem?
that's the third normal form. Yes, but here's the idea. So that's why I think it's not a good one to say like this. This is wrong actually. But I think it would be enough to the example. But
Okay,
here's
let's
the
go then.
idea here. So you need to basically, if you, I will use this as union. There's actually another operator, but I don't have symbols here. So the idea would be if you can split everything and you can join them, and after this join you have the same relation, then that is in fifth normal form. That's the idea of having these joint dependencies. And there's like the sixth normal form requires another definition, which is non-trivial normal form. No, sorry, non-trivial joint dependencies. Just, just
Wait, I have a question.
mm-hmm,
Okay, so if you have an n number of relations and then you do a join with all of them and you
mm-hmm.
acquire R, what is R in this case?
Let me get the example here.
Oh, that's good.
I think it's easier. So here, uh, yeah, they use like, dude, that's a problem that I say. Like, for example, look at the definition the dude gives me. A joint dependency A to like until Z on the alphabet or on R is implied to be by the candidate keys of R if and only if each of A to until Z is a super key of R. So then you need to think, okay, what is a super key? So like that is the whole problematic.
Yeah, I see, I see.
So let's see here the different a formal definition of a joint dependency. I think it's a good exercise. So joint dependency in an area of one.
Wait,
Wait,
if you're gonna read something, put that on the screen. I think it's easier.
yeah, it's easier, right? So let's bring it here.
And I'm curious about the example also because, like I said, I don't know anything about the fifth and the sixth and normal forms.
So in the area of computer science known as dependency theory. So you're gonna ignore. A joint dependency is a constraint on a set of legal relations over a database scheme. Okay, ignore this as well. A table T, I think it's copy. It's like this T is just one T. Okay, like it was because of LaTeX. can always be recreated by joining multiple tables, each having a subset of the attributes of T. So this would be sort of what I try to write here. If one of these tables in the join has all the attributes of the table T, the join dependency is called trivial. So that is not saying much, but I guess that's the definition they give you. So the join dependency, I think it's easier to think of think with an example. Let me bring it here. I took note of this for this matter. Here. So let's try to make it here. So this would be, let me just bring it here, the table, and minimize this. Okay, so the example he's giving us is this. This with a projection, oh man, and an activity again. With the following rules. Does he give any rules? Okay, he does. Okay, so there's this. And he's basically saying, okay, there is a dependency that you can derive on, that he calls, I think, connection trap somewhere. That is basically saying, on the employees, you have a dependency on the project. And on the act, you also have a dependency on the employees. So what is the thing? You would think, okay, like this is just being governed by the key, right? What is the problem? The problem here is when you try to look at what this can cause on the business rule. So let's read. I can't copy this, by the way. If employee E works for project P and a project P has activity A and an employee E is assigned to an activity A, then the employee E works for project B. So this was really convoluted. Let me read it again.
Wait, I
And then we
think I got
break
it,
it down.
but I don't know.
And we'll
I
break it
want to
down.
repeat, yeah.
So if an employee, emp E, okay, I'll write like this. I think it's easier. If an employee E works for some project P, project B, with, I'll use this, and works on project, and has activity, and proj P has an activity A, so act A, and again, and the employee E again has the activity A, then the employee works for the project P. So why did I mean on transitivity? Look at this.
Wait. I have a question. Does the first statement says that the employee E works on project P?
Yes.
Okay, so you have a okay. So I don't see the problem because, as far as I can tell, what you're calling transitivity is that, oh, I have an activity X. This activity is necessarily binded to a project, so you must work there. It's almost like a
So this is a
consequence of having an
yes,
activity.
this is a derivation, right, of something else.
Yes, but this was stated in the beginning also, right?
This was stated in the
Yeah,
beginning.
because the conclusion of
Mhm.
employee E is working on project P. That final part of what you said is in the beginning of the thing. It is there. Employee E arrow project P.
Wait, say the last thing again.
As far as I can tell, in the last part of the statement you said,
Mm-hmm.
thus employee E works at project P. Is that correct?
Okay, I see. Yes. So yes. So it's redundant, right? So
Yes.
that is the part. So it's a cyclic statement. That's what I mean. So you have basically saying, okay, employee. Oh, transitivity is not a very good name, but you can reach to this conclusion. That's what I mean. So you basically have, okay, the employee is working on this, and then the project P has activity A, that and the employee has activity A. Well, so
Thus?
then Yeah. So of course it is stated there. So what? Here's what he means on this. I think is really cool. Here.
Oh, wait. Before going through that, what is the problem of that? Because as far as I can tell,
Okay.
everything is fine.
So they this table is already normalized. I gotta think of that. We're just trying to further normalize. So what we're trying to break here is the possibility to have different sets of values into different relations. So what we should break on this case, I think it's easier if I do this. So here. So if I were to break this, it would be something like this. This is the hardest thing, I think. Like the 6 is way easier, by the way. So the employee number should broken down with the project,
Oh, wait.
and the
I saw
employee
I saw a potential problem.
with
Yeah, because let's suppose that the employee E is working at project Z instead of P in the first part of the end
the
there.
project Z.
Yeah.
Okay.
Then okay, that's fine. And then you say, oh, but project, and then there's this other project P that requires activity A. And by the way, that employee that I just said in the beginning is doing activity A. That doesn't make sense because if
So
he
you're
is
okay.
doing if he is doing activity A, he
hmm
must be in the project P, but he's on Z.
So you're deriving a statement with
Yes,
yes,
you
I get it.
derive. This is like reasoning. Like that's weird, but that's fine.
Let's see if we have the same issue here. So he's basically separating. So this is the thing. So we have an employee with a project, and then we have an employee with some activity, right? And then we have the project with activities. So right now we're just dismembering to this, right?
Yeah, totally.
So this is the same thing. So we're dismembering. And then let me read this. I think it's all worth it. So if such designs are not avoided, an additional integrity constraint is necessary besides the key constraint to guarantee consistency. Uh, that's what you mentioned. This can be avoided by further normalization, namely decomposition that separates the multi-value dependencies into projections. Here, 3, whose columns have no intra-key dependencies. So dependencies within some key, like a part of a key being dependent on another part. Dependencies and thereof are in fifth normal form. So that if you're doing this way, then that means you cannot have this problem. Like think of the Z example, right? You cannot derive a wrong statement that is circular in this sense. If you're separating it like this, this is hard. I think this is the hardest of all. This was the latest one, I think. Like if I'm not mistaken. Let me just bring the 6. I think it is. The 6 is stupidly trivial. I think in a sense it has like a lot of more complicated stuff, but on this sense it is very easy, which is the 6 normal form. We are concerned with breaking everything. Like think of exploding your database. A lot of here's the thing. Like then you would think why do I need that, right? Let me bring here. Why do I need to explode my database like into many different tables like relations? Uh, and the answer for that is like on temporality. That's something necessary if you're thinking of storing everything with a date. Let me give you an example. So let me do something better here. We have the example here, man. Let me bring this. So this here it's not a good one, but let's just do a modification on this table, okay? Let's just remove this, move this. Let's assume there's just this, okay? So just this. So what? Let's suppose uh we want to update this name here. Like Nathan, I don't know. Nathan is now supposed to be, oh, I mistyped his name. It should be Nathaniel. So, okay, if we change this name, that's fine. Like a normal database, you don't care, right? So on fixed normal form, you would do something like this. You would break the person thing and the p name. Let me just type here. I'll not even add populate. And then you should break the thing by the person, assuming that's a key, obviously, with the language. So that's you breaking, right? But why would you want this? Because think about this. If you're dealing with temporality, you don't only have this, you have this. Let me add here. You have a since and until. And what does it mean to be since and until? It means this data got became real. Like it was a real statement from, I don't know, day 1 until day 3. And then, I don't know, now Nathan doesn't like OCaml anymore and he just types JavaScript. He loves it. So this became true from day 3 to, I don't know, infinite. Infinity is the is the way that we are gonna express here to be okay. Nathan still likes it, right? Like this is the last actual data. So this is just a log. Do you agree? This is
Yes.
just something that happened in the past. You're still storing it here. This is the real data now. So this is the thing that is representing what is truthful now. So what you would learn to do in this case would be, okay, so, but think about this. Nathan, we updated OCaml. Did we update OCaml or Nathan? Well, you know in this case because it's very stupid, right? You just have a comparison here.
Yeah, but that can be
But
bad.
but that can be horrible. So what you would do is, okay, you govern the attribute with this since and until here. So then, oopsie,
Then you don't have to care about the language after.
you can fine grain,
Yeah,
right?
exactly.
You can basically say, okay, I updated the name, the language on this day. I didn't update the name. Oh, the name I updated on the other day. So you can audit your database. You literally have the full knowledge of what happened or things on the past. This is really cool, man. Like this was the coolest thing I've seen like so far,
Much easier than the fifth one, though.
and a lot easier. Like super easier. Yes. So so that's it. Like we have more. Like we have boys, COD, normal form. We have another one that I forgot. It's like E something, but I
Okay, so
forgot what it
they
means.
dropped the numbers, so they didn't learn anything with naming schemes through history. Okay.
Yeah, like actually, to be fair, like it should be like 3.5. Like boys COD, it should be like 3.5 normal form. Like it is a really bad. Yeah, so it's not a good one. But anyway, like that's the idea. I just wanted to bring some examples here, like to to try to just like kindle the interest to research. I think this fifth normal form was very confusing, but
No,
the
yeah,
rest I
but
think
that was not
was easy.
expected from you, I guess. You're not expecting to have that time
Yeah,
to talk
I
about that. I do have two questions though.
okay, go on.
Okay, so first, congrats on the presentation. You're getting better at it. The
Oh man,
second thing,
if this is better than what was bad, so,
no, no, no.
yeah,
I also classified the F star one to be good, but I think you got better doing this. Uh,
doing okay,
yeah, because you have much more like script stuff.
freestyling.
Yeah,
Yeah, I scripted. Yes, I
yeah.
had prepared at least.
Okay, so my first question is that in the beginning of your talk, you said that people are too fixed on the getting on following the method, right? And they are not thinking about what they are doing actually, just following the algorithm in order to achieve whatever. And after seeing all the normal forms with the statement that I want to achieve truthfulness, I don't just want to follow a step-by-step recipe. My question is, what are the worst case scenarios that you already saw of people just following the method? Because as far as I can tell, I could follow this method that we did, not thinking about the truthness of it, and I could
Hmm.
achieve similar results. So I thought,
Yeah.
okay, so maybe there's a possibility if I only follow the results, I would achieve
So
something
yeah.
horrible. Do you have
Hmm.
an example of that?
I don't have one, but let me make something. Uh, like when I criticize the method,
And
I'm not
I'm not saying you're
criticizing.
wrong, by the way. That we shouldn't think about the truthness. I'm not saying that.
Yeah, but here's the thing that I think I should make clear. Like I think you got the idea, but let me just add this. When I'm criticizing the method, I'm not necessarily criticizing uh, the behavior, right? I'm just saying when you start to trade, you start to bargain the having the knowledge of something by just introducing mechanisms that you can bypass, like this process of like learning something. That can be very dangerous
Oh yeah.
because think about this. Like I don't have an example, a concrete example to give you, but I can see it's very easy for you to start cargo culting things.
Oh yeah.
You see, like you just pick like okay, like people are doing this. Okay, I don't know, I cannot think about it, so I will just start using what people are giving me to think.
Yeah.
So giving me to do. So
I
you
agree.
just start doing. So you become literally like those monkeys on the experiments that they like fit blocks.
Yeah.
Like that's it. You're literally a monkey fitting blocks on a thing. So
Yeah.
that
Totally
is
agree with
my
that.
problem with the method. Like
Yeah, I totally agree with that.
it's not against you applying only the method if you know the idea behind it, but it's ignoring having the idea, like seeing that as something like ignoring that step. So I have a
Yeah,
problem with that.
yeah, totally relatable. My second question is totally not about that. It's about the sixth normal form. Because as far as I
Okay.
can tell, in the example that you gave, you're using your database for logging stuff.
Yeah. Hmm.
Should we do that?
Okay, so I had this discussion. I had this discussion. That's a good one. Because think about this, like what you want on the philosophy, I think it fits very well. And I noticed it got like so red here. But anyway, like the idea of having a database in the first place is having a source of truth, right? You want to have something that you can look and rely on. So if you want to have auditability, like what is the goal of having uh think of I mean, do you know Kafka? That's a good
Very little,
example.
but yes.
Like queues, what's the idea? Like you're basically storing the livelihood of proof, yes. The idea would be like on Kafka to do something uh like think of event sourcing. You do something on the database, you store, and then you have that thing logged on Kafka because it transmitted the thing from Kafka through Kafka. I mean, so the idea would be to have this thing like all over the time, so you have a clear, direct representation of everything that happened on your thing. But dude, think about this. Like, okay, search to me now, audit to me now on Kafka, which is like this queue. The thing that okay, like I changed Nathan's name here. Like I don't know, Nathan I mistyped. Nathan doesn't like Okomo anymore. He likes JavaScript. Like show me that on Kafka. Like or even worse, I think that Kafka has an even worse problem, which is the state rebuild. If you think of like a total order, Kafka is totally ordered, which means that you don't have. What is total order on relations? It means that every relationship between a set of values, like between two values in a set of values, has a clear order. So that means, for example, natural numbers on the less than. So every number is like less than another number. So you can order all of them, right? But can you do the same thing with like less equals? It's not a totally ordered relation, right? If well, that's not a good one. Let me think of another. Um,
Okay, but my problem, the reason why I asked this is because
okay.
at the point that you are using your database for logging, you are like picking a bucket of new
You,
constraints and
you shouldn't
dumping.
think of this as logs, though. That's my point.
Oh,
You should think of this as well. That's a log, but the idea would be having something there that you knew in the past that was true and ceased to be true now, given some business rule. So you're storing there saying, like, for example, changing Nathan's JavaScript. At some point in time, you know that Nathan changed his opinion. You see?
Yeah.
So that's a whole different thing. Like, there's this talk that I think is really nice, Belani sent me, from Rich Hickey, the closure guy. And there's Datomic, right, which is the database they made there, which is like literally logic. Everything Prolog, it's literally the same thing. Like you're doing queries on your
Hmm.
database, thinking of these predicates. And why do I think that's cool? Because as soon as you have this idea of having logs, these logs or things that you knew in the past were true, dude, you have an insane amount of like options to derive business decisions and so on apart from that. For example, think of yourself as a bank. Um, you are basically saying, okay, I knew that this person spent had this all you have all the log of the person's bank account at some point in time
No, I'm
in
not saying
there.
it's not useful. I'm not saying that like even from the point of view of your like
Hmm.
you are writing history. You're writing the true facts that happened at some point in time
And how they change and
and
so
how they
on.
change and stuff. My the problem that I can see with this is that, for instance, the, at the point that you decide that you're going to have a since and an until column in your database, you need to make sure that you're going to have only one that is like current.
Yeah,
So
that's a constraint. Yes, that's
so
a
you
constraint
start
you gotta
adding
make.
constraints on top of that just
And
because
there,
you want to use it as a log.
dude, there's like so many nasty stuff on six normal form. Because think about this, like think of this table here. Let me go back here. I exploded this thing, right? Now, okay, what is then this relationship here? Like not a person and a language. Well, in this case, it's very simple. But think of like a surname here.
Oh yeah, the semantics can go completely out of the
A
window.
surname, like I don't know, like think of this. Like okay, Nathan, he married. I don't know, but anyway, like he changed his name. Like I don't know. He wants to use Tomás. I think that's his name. And then okay, so he changed his surname, but now okay, I need to add another thing here that is surname. That's something like this. This is a bad example, but anyway, this works. Okay, so now you have this, right? So what is the thing you want? You need to make a view that would basically join all these things here with the same time. You see the
Oh
whole
yeah,
hassle
oh yeah.
you're introducing?
That I
That,
didn't even think of that, but you're correct. The
yes,
join would be hellish.
other things like foreign keys. Like, and to enforce these things to be the same time, you need to enforce this as a foreign key on the other times. So, dude, this can get really hairy. Like, this is really bad. Uh, really bad on this sense of like tooling, you know. Uh, but once you have this, I think it's really worth having
Okay,
the data.
okay, that
But
answers. It is
yes,
worth
but
it, although it's kind of annoying.
I think so. Like
Hmm.
some depends. I think it's depending on the usage. But I think so. I think it's worth it having this knowledge on like the
Hmm.
past.
Okay, so I don't have any more questions. So if Commander not, if both of you don't have questions, I will finish the recording. So any questions?
Oh yeah, Nathan said something like immutability. That's essentially immutability at database level.
Yes, basically.
Which, by the way, like was a problem back then because well, the discs they were more expensive, right? But now that everything is cheap, like
And
pe- people today they think of like redundancy as like discs being cheap as a uh,
as an argument in
excuse.
favor of redundancy.
Redundancy, yes, but I'm not using it as a redundancy. I'm using it as storing things that were true, like which is the this
Yeah,
logging.
and I'm not even saying that you wouldn't have problems. Like, for instance, if you decide that you don't want to use the database as a log to have the past information, but you want to have the information somewhere else, then you have a problem because you need to sync those.
Dude, well, yes.
Whatever you're doing in the database, it needs to communicate back to the other guy saying, oh, this is not true anymore. Please mark that up.
I'll say something that Beleni brought up, and I think there was a little step further on craziness, which was he wanted to make an entity That was an idea, a suggestion he made. I think it's a valid one, though, but which was to make every entity, every module, like in your system, that does something, that thing to log on the database. So you're logging the behavior of the algorithm as well. So you have
Oh.
like, so that is another level.
Yeah,
Like
but
I,
that's like that's not even saying that storage is cheap. It's saying that storage is for free. Like that's
that's
crazy
true.
town.
No, but I would say like that's more on the idea of okay, your story now you're having a real representation of everything you have, right?
Yeah.
Your database is mapping all the thing, like everything that is happening from top to bottom.
Oh
Like you
yeah.
have everything stored there. So I think in that sense it's cool, but yes,
You could
it's
even put the git blame there. Why not? Even anyway.
well, yes, you could.
Anyway,
That
so
could
if
be
you don't
very
have any more
useful.
questions, I will finish recording. Nathan, Commander. So I don't think you guys have questions. So stop recording. And thanks, Mageta, by the way.